Hi everyone, hope you all are doing good and welcome to this class on number system. So my name is Nishant and I'll be taking this session on number system. Now number system I would say is the most important chapter for any competitive exam. You will get plenty of questions from this because it has so many parts. And number system as a chapter you might not have been taught in school or college, because it is not a chapter really, it's a combination of a lot of different concepts. So we'll start with classification of numbers, where we'll look at real numbers, imaginary numbers, complex numbers, rational number, irrational number, prime, composite, even, odd. So various types of classification. Then we'll go to rules of divisibility, sum of natural numbers. In subsequent classes, we'll go to LCM, HCF. We will look at cyclicity of last digits to last two digits, divisibility, factorials and whatnot. So a lot of things under this. A very interesting chapter. So let's get started on this. Okay. Let's start with classification of numbers. And if you see here, the first classification that we do for numbers is basically we divide numbers into real and imaginary numbers. Okay, so first thing is real and imaginary. If you remember imaginary numbers, you would have been taught in school, but just to freshen up and brush up your mind, I hope you all know that you cannot have a negative square. Okay, so for example, any number, for example, if you take plus 5, square of plus 5 will give you 25, which will be plus, and square of minus 5 will also give you plus 25. So a square will always be a positive number. So if I tell you that there is a number which is a square, let's say I square, and this is equal to minus 1. Okay, I'm sure you will say that this is not possible. Okay, yes, very much this is not possible. And in fact, this is the whole premise of a imaginary number, that we imagine I square to be equal to minus 1 or I to be equal to under root of minus 1. Okay, and this is an imaginary number, this because this obviously is never possible. I square is equal to minus 1 is never possible. So any number which has I attached to it, for example, if I write 5i, 6i, 10i, then this is nothing but a imaginary number. Okay, just remember that. If we have to draw a number like this in the plane, in the two-dimensional plane, I'll tell you how we'll do that also. But remember, any number with an I attached to it is an imaginary number. And if you combine a real number and imaginary number, if you combine them, then what do you get is a complex number. So if I write 3 plus 5i, 3 plus 5i is a complex number because it has real number also and it has a imaginary number also. It has both the components, hence it is a complex number. And you represent a complex number on the vertical plane. This axis, the x-axis is taken as real and the y-axis is taken as imaginary, and then the number is plotted. Okay, so one axis we imagine as an imaginary axis, and we plot a complex number. Okay, but imaginary numbers are normally beyond our scope. You don't really have to go deep there, so we will not go much there, and rather we look at the next classification, which is very important, which is for real numbers. So imaginary numbers we are going to ignore, and we are going to look at real numbers, and real numbers can be classified as rational numbers and irrational numbers. Very, very important. Rational numbers and irrational numbers. Okay, let's focus on this a bit. So let us understand what are rational numbers and what are irrational numbers. Now, any number which can be written in the form, and listen to this carefully, very important, any number which can be written in the form P by Q, okay, where P and Q are integers, they're element of integers, and Q is not equal to 0. That is a rational number. So this is the definition. Integers I hope you know, but just in next few minutes I'm going to explain to you integers also. So integers are basically whole numbers where the denominator is 1. Okay, so minus 5, minus 10, plus 1, plus 5, plus 10, even 0. Okay, so all these are called as integers. So the numerator as well as the denominator, both of them should be integers, and denominator cannot be 0. If the denominator is 0, then obviously your number will become indeterminate. So this is the definition of a rational number. Okay, and most of the numbers that we use are rational numbers. The second category is irrational numbers. Okay, unfortunately we don't have a definition for irrational numbers. All that we say that any number which is not of this type is an irrational number. Any number which is not of this type is an irrational number. But I'll give you a definition today. I'll give you a definition for irrational number, very, very important. Okay, but do you recall any irrational number? In fact, there are more irrational numbers in the universe than rational numbers. Okay, between every two rational numbers, there are infinite irrational numbers. Okay, most common example of irrational numbers are square roots of numbers which are not perfect squares, cube root of numbers which are not perfect cubes. So your root 2 is an irrational number, root 3 is an irrational number, root 5 is an irrational number, root 7 is an irrational number, root 8 is an irrational number. All these are irrational numbers. Okay, and not only root 2. You take third root of 2, you take fourth root of 2, you take fifth root of 2, you take sixth root of 2, all of them will be irrational numbers. So you can imagine how many irrational numbers you can get. So this is one. Two very common irrational numbers that we use, one of them is pi. Pi, I'm sure you remember, you take the circumference of a circle as 2 pi r, you take the area as pi r square, that pi is an irrational number. But then you can say, why, how come pi is an irrational number? Pi is 22 by 7. But mind you, any book that you see, it will be mentioned like this. Pi is equivalent to 22 by 7. It is not equal to 22 by 7. So this symbol here basically means that it has been approximated to 22 by 7. It is not exact value. It is an approximate value. Okay, and the actual value of pi is 3.1415925, and it goes on like this. This is the actual value. But 22 by 7 is actually 3.142856, and it goes on like this, and it actually starts repeating. So you can see till 3.14 the value is same. After that the value actually starts differing a bit. So pi as 22 by 7 is an approximation. Okay. Second irrational number that we use on a daily basis is Euler's number. Okay, which is represented by E. And this is very commonly used, especially in log to the base E. Okay, so Euler's number E is equal to 2.718281 and so on. So Euler's number, actually, again, this is an irrational number. Third irrational number, not so much used, but something that you should know, is a golden ratio. Golden ratio is represented by phi, or this symbol. This is approximately equal to 1.618 and so on. This is again an irrational number. So three important irrational numbers. Golden ratio, if you've not heard, golden ratio has been used in a lot of places, and the definition wise it is defined as that if you have a line and you divide the line in parts of x is to 1 such that x plus 1, the whole upon the longer part, is equal to the longer part upon the shorter part, then here the value that you get for x, that is the golden ratio, which if you solve this, it's a quadratic, you will get the positive root, you will get at 1 plus root 5 by 2. 1 plus root 5 by 2. This is your golden ratio. And golden ratio, why do we call it? Because we say aesthetically, anything, for anything to be pleasing or beautiful, the ratio of the length to width should be 1.618. In fact, Mona Lisa the painting and so many other beautiful paintings and in fact beautiful people, it is said that normally the length to breadth of their face is in golden ratio. Okay, so this is golden. So not digressing much, but these are few very important irrational numbers that we use. Okay, coming back to what I was saying, I will give you a definition for irrational numbers. Now if you see all these numbers that I've told you, we have converted them to decimal, right? So let's focus a bit on the decimal side. And on the decimal side, if you see, we basically can have what we call as terminating decimals. Okay, so terminating decimals, I mean, so let's say you have decimal. So decimal can either be terminating. What is terminating decimal? Anything that gets over 2.73, 2.735, 2.7351. So this has 2 digits after decimal, this has 3, this has 4, you can have 6, 7, 8, 20, 40, whatever, but it terminates, means it gets over. And if it terminates, then obviously you can convert this by putting 10 to the power n, whatever is the number of digits in the decimal, that many zeros can be put in the denominator. And it can be converted into a fraction of the type p by q, where q is not equal to 0 and p and q are integers, right? So terminating decimal is always a rational number. Okay, first thing. Then second category is what we call as non-terminating. You can have decimals which are non-terminating. Okay, for example, let me erase a bit here. Let me erase all this so that I can explain this to you. So non-terminating can be a number like 2.373737, so on. This type of number is called a recurring number. Okay, so non-terminating can be recurring. Okay, one category. Second we'll look at. Now, is this a rational number? Let's see. So this number can be written as, let's say x is equal to 2.37 bar. Whatever are the number of digits that repeat, we put a bar on top of it, and that is the number of digits is called the period. So this number has a period of 2, which means 2 digits repeat. Fine. Okay. For some time, let's not bother about 2, which is before the decimal. So we'll take our number to be 0.37 because I'm only concerned with after the decimal. So what you have to do, if the period is 2 here, all that you have to do is multiply the number by 10 to the power 2, which is 100. So 100x will be equal to 37.37 bar, and let's subtract them. 100x minus x is 99x is equal to 37. So x is equal to 37 by 99, and your number will be, because we had a 2 also before, so your actual number will be 237 to the power 99, which is nothing but a mixed fraction, right? So you can see very easily a recurring decimal can be converted to a fraction, and there's a formula. I want you to understand the formula. The formula is nothing but whatever is your recurring decimal, keep that in the numerator. So 37, so keep 37 in the numerator, and the period is 2. Period means number of recurring digits. So there are 2 recurring digits. Put 2 9s in the denominator. That's all. So you put 9s equal to the number of recurring digits. So 2 9s, put two recurring digits, put 2 9s in the denominator. That's all. And you can easily convert this into a fraction. Okay. So recurring decimals are rational numbers. There can be one more type of recurring decimal. It can be, let's say, 3.3717171, this type, where if you see 71 is recurring but 3 is not recurring. So in fact this number is 3.371, but recurring is only 71. After decimal also everything is not recurring. Okay, this is called mixed recurring. This is called pure recurring. So this is a pure recurring, this is a mixed recurring. Okay. Is this a rational number? Let's see. Let's again assume x to be 0.371. We'll not bother about 3, which is beforehand. Now, first thing that you'll have to do, we'll have to make this mixed recurring into a pure recurring. So there's one digit that is non-recurring. So let's multiply this by 10 to the power 1. So you get 10x, which is equal to 3.71 bar. Now this is a pure recurring, which has a period of 2. So let's multiply 10x by 10 to the power 2, which means 100. You'll get 1000x. So 1000x is 371.71. Okay, let's subtract them. You will get 990x is equal to 371 minus 3, which is 368. So x is equal to 368 upon 990. So you can see that this is also a rational number. And I want you to understand what we have done here. For if you want to convert into a fraction directly, the numerator is nothing but the whole part after the decimal, 371. Please write 371 and subtract the non-recurring part. This is your numerator. And for the denominator, whatever is the number of recurring digits, put 9. So there are 2 recurring digits, put 2 9. There is one non-recurring digit, 3 is non-recurring, so put a 0 for that. So every recurring digits get a 9, every non-recurring digit gets a 0. So you have 368 upon 990, you get this. Okay, so all recurring decimals are rational. Okay, then the type is that now let's assume that you have a number equal to my Euler's number, or equal to my pi, or equal to my golden ratio, which is so I'm just taking a random number, 0.1427563911328. It just goes on. It goes on without any pattern. And if there's no pattern, now how will you simplify this? How will you convert? How do you know how many zeros to put in the denominator? You don't. So this number cannot be converted to a rational number. It cannot be converted to a fraction. So this type of number is called non-recurring. Okay, and non-recurring is irrational. Okay, so any number which is non-terminating and non-recurring is an irrational number. So this is the definition of irrational number which I wanted to give you. So any number that can be represented in the form p by q, where p and q are integers and q is not equal to 0, is a rational number. And any number which is non-terminating and non-recurring is an irrational number. Obviously the first definition is for a fraction, the second definition is for a decimal. Okay, so I hope we are clear. Great. So let's come back. And what else we had? So rational and irrational. Now rational numbers can be divided into fractions and integers. This is simple. I hope you understand. Fraction basically are of 3 types. So fraction is a by b, where again a and b are integers, obviously goes without saying. B should not be equal to 0, and because we are calling it a fraction, b should not be equal to 1 also. If b is 1, then actually it's an integer. So b should not be 0 or 1. Okay, fractions are of 3 types, a by b. If a is less than b, then it's called a proper fraction whose value is less than 1. For example, 2 by 3. If a is greater than b, then it's called an improper fraction. For example, 3 by 2. And then same improper is also converted into another type which is called a mixed fraction. So this 3 by 2 I can also write as 1 by 2. Okay, where now if you have to convert from here to here, you multiply 2 into 1 plus 1. Okay, and it becomes 3 in the numerator. Okay, so 3 by 2 obviously means 1.5, right? So you divide and then half is your remainder. So improper and mixed are same, just different ways of writing. So I have proper fraction, I have improper fraction, and I have mixed fraction. Then we come to integers. Integers are of 3 types. We have negative integers, we have positive integers, and we have 0. So remember that 0 is not counted in negative integers, it is not counted in positive integers, it is counted separately. So if a question says non-negative integers, that means 0 plus positive integers. And if a question says non-positive integers, that means 0 and negative integers. Okay. If a question says positive integers, then obviously you'll take positive. Negative, you'll take only negative. Okay. But understand that. So your positive integers are from +1 to plus infinity. Negative integers are -1 to minus infinity. And 0 obviously is 0. Okay. Good. And I hope we all are aware that if you add two negative numbers, the sum will be negative. But if you multiply two negative numbers, then the product will become positive. In fact, if you multiply odd number of negative numbers, the product will remain negative. Okay. Otherwise, the product will always be positive. Okay. Whereas in sum, if you have negative numbers, only negative, obviously it will remain negative, negative, positive, then it will depend on the value. Okay. Now, only positive integers are also called natural numbers. If you add 0 to that, so 0 plus positive numbers, positive integers are called whole numbers. Okay. So 0, 1, 2, 3, 4 up to infinity. This is a series of whole numbers. If I remove 0, then this is a series of natural numbers. And natural numbers, we will look at it in a moment. We have some good concepts there which we will look at. Okay, then let's focus on natural numbers. Now natural numbers can be divided in so many ways, but I'm dividing them in mainly two ways. One is even and odd numbers, and second is prime and composite numbers. Okay, so let's look at here a bit. So even and odd numbers. Even and odd numbers. Obviously, any number which is of the form 2x, where x is an integer, that is an even number, and any number which is of the type 2x plus 1 plus minus 1 is an odd number. That I think is very, very obvious. Now, there are some addition and multiplication rules here which I should know. Let's say if I'm adding even plus even, you'll get even. Odd plus odd, this will also give you even. Odd plus even will give you odd. And odd plus even or even plus odd is same. So sequence does not matter. There are three possible combinations. If you add three of them, even plus even, you get even. If you do even plus odd, you get odd. You do even plus odd, you get even. And you do odd, you get odd. So what pattern do you see here? Very important. When you have one odd number, the sum is odd. Right? When you have here also, and you can see here also, one odd number gives you an odd sum. When you have two odd numbers, here and here, you get an even sum. When you have three odd numbers, you get an odd sum. Okay. Similarly, and here even number plays no role. In addition, even number plays no role. So the rule here is that odd number of odd numbers gives you what? Odd sum. Odd number of odd numbers gives an odd sum. Okay, this is a summation rule, very important. Even number plays no role here. Okay, then second part is multiplication. If you multiply even into even is even, even into odd is even, odd into odd is odd. Let's take 3. Even into even is even. Even into odd is even. Even into odd is also even. Odd into odd into odd is odd. So now, do you notice when are you getting an odd sum? Odd product? Odd product you are getting only in this case and in this case. Okay, so what is the rule here? All odds give an odd product. So in fact, in product, it is the even number that plays a role. If at least one even number is present, the product will become even. The product will be odd only when no even number is present. That means all the numbers that are getting multiplied are odd. Only then the product will be odd. Otherwise, the product will always be even. Okay, something for us to remember, and we will be using this concept in some questions. Okay, so these are some even odd implications which we should know how they behave. Then the second part that we had looked at was prime and composite numbers. Let's understand this also. So now prime and composite numbers, we will do some questions on them just in a bit. So prime and composite, what are they? Let's look at number 6. Number 6 can be divided by what numbers? Number 6 can be divided by 1, 2, 3 or 6, right? These are called the factors of 6. Factors, or you can also call them divisors. So number 6 has 4 factors. Whereas if you look at number 3 can be divided by 1 and 3 only. If you look at number 11, it can be divided by 1 and 11 itself. So they have 2 factors. So any number that has only 2 factors is a prime number. Okay. Any number that has only 2 factors, and those 2 factors also are 1 and the number itself. There's no other factor. So 1 and the number itself, any number which has only 2 factors is a prime number. And any number which has more than 2 factors is a composite number. Okay, very simple definition. There is only one even prime number, that is number 2. Otherwise, there is no other even prime number. All other prime numbers are odd. Okay, and then there's a natural question. You may ask me about 1. How many factors that 1 has? 1 has only 1 factor. 1 can be divided only by 1. So in fact, 1 is called neither prime nor composite. 1 is called a unique number. So 1 is a unique number. It is neither prime nor composite. Okay, so very simple. Your numbers which have only 2 factors, let's list down those numbers, some of them. So 2 is the first prime number, 3 is the next prime number, 5 is the next prime number, 7 is the next prime number, then you have 11, then you have 13, then you have 17, then you have 19. All these are prime numbers. If you write from 1 to 100, then up to 50, you have 15 prime numbers, and from 51 to 100, you have 10 prime numbers. Total 1 to 100, you have 25 prime numbers. Okay. Now, how to identify prime numbers? Very important. How to identify prime numbers? Let's say I give you a number 97. Is 97 a prime number? Okay. Unfortunately, there is no formula till date to identify a prime number directly. There are 2 steps that you'll have to do. The first step is you have to check whether the number is of the type 6n plus minus 1 or not. All prime numbers are of the type 6n plus minus 1, where n is a natural number, except 2 and 3. Okay, so this is except 2 and 3. Minimum value of n you will take 1, and if you take minus sign you will get 5. So you will not get 2 and 3. This starts from 5. Okay. Now, a lot of people interpret this condition wrongly. Understand, all prime numbers are of the type 6n plus minus 1, but I'm not saying that all numbers of the type 6n plus minus 1 are prime. Okay, so being of the type 6n plus minus 1 is a necessary condition. It is a necessary condition, but it is not a sufficient condition. This alone does not guarantee that it will be a prime number. But if the number is not of this type, then you can surely say that it will not be a prime number. For example, here itself in this series, if you see 5, 7, 11, 13, 17, 19, all you can make from this. Next number is 23 and then you will get 25. Okay, 25 is a 6n plus minus 1 number. If you take n is equal to 4 and plus 1, you will get 25, right? But you can see that 25 is not a prime number, right? Similarly, if you take n to be 7, how much do you get? 7 into 6. 7 into 6 is 42. You will get 41 and 43. Both of them are prime, but you take n is equal to 6. If I take n as 6, 6 into 6, 36. 36 minus 1, 35. 35 again is not a prime number. So all numbers of this type are not prime, but the number has to be of this type. That is the first condition. If the number passes this test, then the second test is you take an approximate square root of the number. For example, 97. Approximate square root of 97 is 10. Okay, the next square, perfect square is 100. 100 square root is 10. So 97 is 9 point something. Okay, you can take 10, you can take even 9. The lower integer is also fine. So 9. Okay. Now you will have to check the divisibility of 97 with every number from 1 to 9. That's all. Check 1 to 9. If it is not divisible by any number from 1 to 9, then it is a prime number. Okay. So 2 steps. First step, the number has to be of this type. And second step, you take an approximate square root, you take the lower integer, and then you check the divisibility. Divisibility rules we are going to discuss just in a while. So you check the divisibility. And if the number is divisible by any number between 1 to 9, then it is not a prime number. If it is not divisible, then it is a prime number. Okay, so these are 2 steps that you do to check whether a number is a prime number or a composite number. Okay, and prime composite numbers will do a lot of questions and a lot of concepts there. There's another variety which is called co-prime, which we'll also discuss in the next class, not right now. Fine. So this is basically your classification of numbers. If you see, we have covered till here. Okay. Now let's quickly do some questions on this. Okay. So first look at rationally irrational numbers. 3.37. We want to convert this to a fraction. I told you 37. Just focus on 37. This is a pure recurring. So you write 37. And the period is 2. There are 2 digits which are recurring. So you have 2 9s in the denominator. So this is the equivalent of 0.37 recurring. And you have a 3 before decimal. So you put a 3 here. So this is your number. Right? This is a mixed fraction. Of course, you can convert this into an improper fraction as well. 99 into 3 is 297. 297 plus 30, 327, 334. Upon 99. If you want, you can convert this. But this is your pure formula. Similarly, second one, you can see there are 2 recurring digits and 2 non-recurring digits. So if you remember what I told you, you write the whole number and subtract the non-recurring part. In the denominator, 2 recurring digits, so 2 9s, 2 non-recurring digits, 2 zeros. And then we have a 2 here. So you'll put a 2 here. Okay. So this will become 2. 4, 5, 7, 3 minus 45. So if 73 minus 45. So 45 is 23 plus 5, 28. Of course, this can be simplified. It can be cancelled by 2 and 4 and all. You can do that. But it's pure application of the formula. Similarly, third one, 147 you can see is recurring. 147 is recurring. Okay, so this number is the type 1.46147. Okay, so again same logic. Numerator will be 46147 minus 46. 3 recurring digits, so 3 9s, 2 non-recurring digits, so 2 zeros and 1. Now 47 minus 46 is 1, 0, 1. So 46101 upon 9990001. this becomes your answer for this question. Okay, so this is a very simple application of this concept. Okay, let's look at, is 1997 a prime number? What did I tell you? What will you require to do for this? First, is this of the type 6n plus minus 1? So now this is a hit and trial. So if you take n as 300, you'll get some 1800. I still need about 190 more. Okay, so I take 30 more. I take n as 330. If you take 330, you'll get 1980, right? This will give you 1800. This will give you 180. And then I need, let's say, 18 more. So I'll need how much more? 3 more. So 333. 333 will give me 1998 and then minus 1. Okay, so yes. So 6 into 333 minus 1 is 1997. Hence, it passes the first test. It is of the type 6n plus minus 1. But I told you this is not sufficient. Second step is under root of 1997. What is the approximate under root? Now for approximate under root, you have to think of the under root just before this or just after this. So 1997, if you see, 2025 is a square root of 45. Okay, that is what comes the closest. So this is 1997 is slightly greater than 44. Right? What is 44 square? 4 into 4, 16, 6, 1 carry, 8, 16, 17, 1 carry. This is 16, 17. Here 1776. Is that correct? Let's check. No, this is not correct, right? Yeah, so that's what I wanted to check. Basically, what do? You do 4 square, which is 16, 1 carry, then 4 into 4, 16, and then double of 16, 32, plus 1 carry, 33, so 3 carry, 16 and 3, 19, 1936. So obviously you can see that this is greater than 44 square. So 44, now you will have to check the divisibility of 1997 with every number from 1 to 44. Okay, this obviously you will not be able to do right now because I have not told you the rules of divisibility, but once I tell you, you can apply that, come back to this question and solve this. Okay, but these are the 2 steps that you basically need to solve any question for whether it's a prime number or not. Though that's not a question that you're going to get in an exam, but you should be aware. That's the whole idea. You should be aware. Okay, let's look at this question. Looks interesting. P1, P2, P3 are 3 consecutive prime numbers such that P1 into P2 into P3 is this. What is the value? Okay. Now this can be complicated because multiplying 3 numbers, this is the product that you get. So let's take help from the answers. You see the answers are very close. And if you see it is sum of 3 numbers, the average is about 50, right? 50 to 60. So let's look at prime numbers around 40 to 60. What are the prime numbers between 40 to 60? 41 is a prime number. 43 is a prime number. 47 is a prime number. 51 is not a prime number. 53 is a prime number. 55 is not. 57 is not. 59 is a prime number. 61 is a prime number. Okay. Now if I add first, second and third, I'll get 120, 131, which is 2 less. Let's add the last 3. If I add the last 3, I'll get 120, I'll get 173, okay, which is given to me. So this is a possibility. Okay, what is the next prime number after this? 67. Okay, if I add these 3, how much do I get? I get 60, 60 is 120, 170, 187. So fourth one I don't get. Okay, if I add these 3, then how much do I get? I get 159. I don't have that also, right? So the only number that I'm getting is 173. Is that it? Because remember, these are 3 consecutive prime numbers. So consecutive prime numbers, in fact, you're getting 173. 179 I'm not getting. The number is exceeding. 169 also I'm not getting. We have taken these 3, then these 3. So actually nothing else is possible. If I take these 3, then you will get again 143. So 173. Okay, let's just do a very quick check. In fact, this is the only combination, so this has to be the answer. But your 53 into 59 into 61, if I just do a last digit check, 3 into 9 is 27, so 7 into 1 will give me 7. So the last digit will be 7. So this obviously has to be the answer. No other number gives you that combination. So 53, 59 and 61. Okay, as simple as that. That is what your answer is. Fine, you can obviously go the long way, but there is absolutely no point in doing that. Okay, let's do one more check just for our satisfaction. 190747. Let's divide it by 53. If I divide it by 53, how much do I get? Okay, I get 3 times. So 159, 317. So then not 6 times, will be 318. So 5 times 530. That will give me 265. That will give me 52. 524. 9 times. So it is 530 minus 50, 480, 477. So 7, 477. You get 3599. Okay. Now 3599. Let's divide it by 59. So I get 6 times 300 and 96, 54. I get 354. So I get 5 and 9. So 1 times. So obviously you can see 53, 59 and 61. Okay, so that is the answer. Though this was not required, but this just to check whether our answer is correct or not. Okay, let's move on. Now let's look at divisibility. Very important and very interesting concept. But before we look at rules of divisibility, let's just understand some very simple properties here. So if A is divisible by B, then AC is also divisible by B. Very simple. So if you have number, let's say 36 is divisible by 6, then 36 into multiply with whatever, that will also be divisible by 6. Okay. Then if A is divisible by B, 36 is divisible by 6 first, and 6 is divisible by 3. Then 36 will be divisible by 3. So if A is divisible by B, B is divisible by C, then A is also divisible by C. So all are very intuitive, but just a repeat so that we don't forget this. If A and B are natural numbers such that A is divisible by B and B is divisible by A, then A is equal to B. Okay, because if A is divisible by B and B is divisible by A, that will never happen unless both of them are same. Okay, if A and B are independently divisible by N, that is 36 is divisible by 6, 12 is also divisible by 6, then 36 plus 12 or minus 12 will also be divisible by 6. Okay, if A is divisible by B, 36 is divisible by 6, okay, and let's say 22 is divisible by 11, then 36 into 12 into 22 will be divisible by 6 into 11. Okay, so if A is divisible by B, C is divisible by D, then AC is divisible by BD. Okay, so these very intuitive, but just a refresher so that we do not get confused or make any silly error. Okay, now let's look at the main rules of divisibility. Okay, so these are the rules listed here. I will try to summarize them for you. Very simple. For any number to be divisible by 2, we check the last one digit. Okay. For it to be divisible by 2 square, which is 4, we check the last 2 digits. For it to be divisible by 2 cube, which is 8, we look at the last 3 digits. For it to be divisible by 2 to the power 4, which is 16, we look at the last 4 digits. So if you see 2 to the power n, we look at the last n digits. Of course, here you should ask why. And the answer is very simple. If I have a number 1, 2, 3, 4, 5, and I want to check the divisibility by 2, I am saying check only for 5. So basically the number becomes 1, 2, 3, 4, 0 plus 5. I am saying don't check for this. Don't check means I am assuming that this will be divisible by 2. And because this is a number ending with 0, obviously it is divisible by 2. And hence you need to check only for 5. For divisibility by 4, I am saying check only the last 2 digits because the number can be written as 1, 2, 3, 0, 0 plus 45. And any number ending in 100 is always divisible by 4. So you don't have to check the first part, you only have to check the second part. Same rule applies for 8. The number will become 12000 plus 345, and any number ending with 1000 is automatically divisible by 8. Okay, so now the interesting part is that the same rule applies for 5 also. So 5 last 1 digit, 5 square last 2 digits, 5 cube last 3 digits, 5 to the power 4 last 10 digits, and 5 to the power n last n digits, because the logic is same. If you have to check divisibility by 5, any number ending with 0 is always divisible by 5. Any number ending with 2 zeros is always divisible by 5 square, which is 25. Any number ending with 3 zeros is always divisible by 5 cube, which is 125. Okay, and same rule applies for 10 also. So 10, 10 square, 10 cube, 10 to the power 4. So if you see in one rule, we have covered so many numbers. So 2 to the power n, 5 to the power n, and 10 to the power n. All of them have same rule, check last n digits. Okay, so in the single rule, we have covered how many numbers? We have covered number 2. Let's write here. We have covered number 2, number 4, number 5, number 8, number 10, number 16. All these numbers done. 2, 2 square, 2 cube, 2 to the power 4. Then we have taken 5. 5 square will be 25. That's too far. We have taken 10. Okay. The next set of rules is for 3. Okay, and powers of 3. So 3, 9, 27 and all of them. For them the rule is very simple. 3 to the power n, sum of all the digits should be divisible by 3 to the power n. Very simple rule. So if you have a number 1, 2, 3, 4, 5, you want to check whether it is divisible by 3 or not, just add all the digits, you get 15, and because 15 is divisible by 3, 1, 2, 3, 4, 5 is also divisible by 3. Okay. You want to check whether it is divisible by 9 or not. 15 is not divisible by 9, so this number is not divisible by 9, but it is divisible by 3. Okay, so for 3, the sum of the digits should be divisible by 3. For 9, it should be divisible by 9. For 27, it should be divisible by 27. So this takes care of 3, 9, 27 as well. Okay, then what numbers are left? We have, if I see here, 2, 3, 4, 5, 6 is left, 7 is left, 8 is done, 9 is done, 10 is done. 11 is left, 12 is left, 13 is left, 14 is left, 15 is left. Let's say we are doing up to 16. Okay, fine. Then let's look at 6. 6, 12, 14, all these numbers are composite numbers. Okay, and for composite numbers, there is no particular rule of divisibility. You will have to break it down into prime factors. So for 6 basically is 2 into 3. So 6 will not have its own rule. You will have to apply the rule for 2 and 3. Okay, so 6 is also taken care. Similarly 12. 12 is 4 into 3. You have a rule for 4. 4 also is a composite number, but 4 has its own rule, very simple. So basically you apply the rule for 4 and 3. Similarly 14. 14 you apply the rule for 2 and 7. Though 7 I have not told you, but I'll tell you. So don't bother about composite numbers. Composite numbers have to be broken down into prime factors. Okay. Then comes number 15. 15 again is 3 and 5. So this also you know. Okay. Then we have number 11. 11 is interesting. 11 is an interesting number, because rule of 11 is interesting. If I have this number, okay, let's say, you know what is this number called as? Or not this number, this type of number, it's called a palindrome. Now, palindrome is a number which can be written same both ways. Palindrome is also a word which can be read same both ways. Okay, so this is a palindrome. Now, the rule for 11 is that you add all the digits at odd places and add all the digits at even places. So basically I will add, starting from the first one, 1st, 3rd, 5th, 7th and 9th. That gives me how much? 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 3 is 12, 12 plus 1 is 13. And then I add 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 2 is 12. So this is what I have. Is the total correct? 2, 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 3 is 12, 12 plus 1 is 13, and the second set is 2 plus 4, which is 6, 6 plus 4 is 10, 10 plus 2 is 12. Okay, so this is what you get. Okay, so add all the digits at the even places, add all the digits at the odd places and subtract them. This difference should be 0 or multiple of 11. This difference should be 0 or a multiple of 11. Okay, that is not the case here. So this number is not a multiple of 11. As simple as that. This number is not a multiple of 11. Okay, so that is the rule for 11. So 11 also done. The only number left is 7 and 13 now. Now these numbers are a special category of numbers. If you see 7, 13, 17, 19. These are a special category of numbers which do not have a rule of its own, but we have made an empirical rule. Okay, we have made an empirical rule, and that rule you should understand, and that also can be applied wherever required to check for these numbers. This rule basically says, let's look at 7. I take a number, let's say 3528. Okay, and I want to check whether this number is divisible by 7 or not. So understand the steps very carefully. Remove the last digit. Double the last digit. So the last digit was 8. Double it, which is 16, and subtract it from the remaining. So remove the last digit, double the last digit, and subtract it from the remaining digits. Okay, how much do I get? You get 336. Is this number divisible by 7? If you know, well and good. If you don't know, repeat the same step. Remove the last digit, double the last digit, and subtract it from the remaining numbers. 21. Is 21 a multiple of 7? Yes. You know, very good. If you don't know, repeat. Again, remove 2, remove 1, double the last digit, subtract it, you will get 0. So you can keep repeating till you get 0 or till you get a multiple of 7. Okay, so that is the step, and that's why the step is written as x minus 2y. Minus 2y is you double and subtract. So, and here you see y is the last digit and x is the number formed by the remaining digits. Okay, so x minus 2y. So you basically double and subtract. Same method applies for 13, 17, 19 also, with some variation. For 13, you can see it is 4 times and added. For 7, we were doing it double and subtracting. For 13, it is made 4 times and added. For 17, it is 5 times and subtracted. For 19, it is 2 times and added. So slightly different for each one of them. But these are rules which, if required, can be used to check for 7, 13, 17 and 19. Okay, though we very rarely use them, but you should be aware. Okay, so these are my rules of divisibility. For basic numbers, we have taken numbers up to 16. Let's apply this in some questions and see. So we have, first question is 258 is reduced by 6 or not. Now 6, you know, does not have a rule of its own. So 6 will be converted into 2 and 3. And for 2, you check the last digit is 8, so 2 is yes. And for 3, you check the sum of the digits. So 2 plus 5 plus 8 is 15. 15 is divided by 3. So it is divided by 3 also. Hence the answer is yes. Okay. Then we have to check for 14. Now 14 is 2 into 7. So first we check for 2. Last digit is 6, which is an even number. Hence it is divisible by 2. And for 7, you know the method. So 8, 2, 4, 6. 6 we remove, we double. So we get 812. 812 again you may not know. So 2 remove and double. 4 you get 77. 77 obviously is a multiple of 7. So yes. So the answer is yes. And then 24. 24 is 8 into 3. Okay. For 8, check last 3 digits. 840. So 840 is divisible by 8. Yes. And for 3, we have to check the sum. So 18840. So that is 8 plus 1, 9. 9 plus 8 is 17. 17 plus 4, 21. 21 is a multiple of 3. So yes. So the answer is yes. Okay. So all the answers are yes. And these are some simple checks that we do to solve this. Let's solve few more questions on this. So we have now this number and we have to check the divisibility by 99. Now 99 you know will be 9 into 11. For 9 it will be sum of digits. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 1 is 8, 8 plus 10 is 18. 18 is divisible by 9, hence the number is divisible by 9. Then for 11, it is a sum of digits at odd and even places. So 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 5 is 9. And 2 plus 2 is 4, 4 plus 5 is 9. It is 9 minus 9, which is 0. So it is multiple of 11 also. Hence the number is a multiple of 99. Okay. So as simple as that, we can apply the rule. Next question. A number is divisible by 44, where x and y are single digit whole numbers. What is the maximum possible value of x plus y? Okay. Now 44 is 4 into 11. So the number has to be divisible by 4. For divisible by 4, the last 2 digits should be divisible, which means YO should be divisible. Okay. So YO should be divisible. That means Y can be 0. It is a whole number. So 0 is divisible by 4. It can be 20. It can be 40. It can be 60. It can be 80. All these are divisible. So the possible values of y are 0, 2, 4, 6, 8. Fine. Then we apply the rule for 11. For 11, the rule is x plus 6 plus 7 plus 0, right? So x plus 6 plus 7 is 13, 13 plus 0. So 13 plus x is one side and the second side is 3 plus 2, which is 5 plus y is 5 plus y. Okay, now we already know the values of y, so we'll put each value one by one and we'll see what do I get. So if I put y is equal to 0, this will give me 5. Okay, so 13 plus x obviously is greater. So for that to be multiple, my 13 plus x minus 5, obviously it can't be 0. The only value it can be is 11. For it to be 11 plus 5, 16, x has to be 3. Right? If x is 3, then 13 plus x will become 16. 16 minus 5 will get 11. That is the only possibility. Similarly, if I put y is equal to 2, here, then this will become 7. For this 13 plus x is equal to 18, that means this is equal to 5. Right? So you can see that x value is increasing by 2. Okay. And again here 0 is not a possibility. 22 again is not a possibility. Okay. Because if I make this as 22, then x has to be greater than 9, which is not possible. Okay. If I take y as 4, then this becomes 9. If I put this as 9, this is 20, x becomes 7. If I put this as 6, then this becomes 11, 22, this will become 9. And if I put y as 8, this becomes 13, 13 plus 11 is 24, so x will have to be 11, which is not possible. So these are 4 possible combinations of x and y. The question is, what is the maximum possible value of x plus y? So you can see that x plus y is 3, 7, 11 and 15. So 15 is the maximum possible combination that we can get. So that will be the answer for this question. Okay. Anything else? Can we do anything else here? Just keep in mind one more thought, that when y starts becoming bigger, especially in the last case, when I was taking y as 8, so then your 5 plus y is 5 plus 8 is 13, right? So 13, so actually I can also subtract in reverse, because it says your difference, one is sum of odd numbers, one is 7, or sum of even numbers. Their difference should be 0 or a multiple of 11. It doesn't say odd minus even or even minus odd. It can be either way. So I can even do 5 plus y minus 13 plus x. This also can be 0 or a multiple of 11. So if I take y as 8, this becomes 13. And if I take x as 0, then also 13 minus 13 is 0. So with y as 8, x is also 0 possible. Okay, though that gives you a sum of only 8. So that doesn't help. I want to maximize the sum. If you take x as 11, if you take y as 11, we had taken 8, so 6. Yes, if you take 6, then it is 11. Then in that case is not possible. Only in the last case, x 11 was ruled out, but 0 and 8 is a possibility. Okay, though that doesn't give you higher sum. The highest sum you get is this. Okay, fair enough. Let's move on. Okay. Let P be the set of even integers A such that A lies between 125 and 275. A is divisible by 7 but not by 11. How many elements does P contain? Okay, so basically we want multiples of 7. What will be the first number after 125 which will be divisible by 7? You will have 70. And then you need about 55 more. So 70 plus 56. 126 is the first number, right? This is 10 times and this is 8 times. So 18 into 7 is the first number. Okay, and let's look at the last number. 280 is a number. 280 is a multiple of 7. Before 280 you have 273. This is 126 and the last number will be 273. which will be 39 into 7, right? So basically from 18 to 39. Okay, 18 to 39 is how much? 39 minus 18 plus 1, remember, because you have to count the ends also. When you have to count the ends, you always take the difference plus 1. So that will give you 39 minus 18 is 21 plus 1, 22. Okay. But then the question also says we want only even integers. So when you want only even integers, then you will have to take half of this. Okay, you are starting with an even one, you are ending with an odd one, so you basically have to take half of this. So this 22 automatically will become 11. So the 11 such numbers. And now you also have to leave multiples of 11. Okay, now how many multiples are we counting? Basically numbers which are multiple of 7 as well as multiple of 11, that means they should be multiple of 77, right? So let's just very quickly check. We have 77, we have 154, okay, then you'll have 154 plus 77, which is 231, and the next one will be beyond 275. So basically I am getting two numbers, okay, out of which one is even. So I'll subtract that one. So I get 10 numbers which satisfy the condition. So my answer is second choice. There are 10 numbers between 125 and 275 which are even, which are multiple of 7 and which are not multiple of 11, right? Okay. There's another method of doing this question which we'll do in the next class when we look at factorization. Okay, and factorization has a very nice method to check that which numbers are multiples of certain numbers or not. Okay, let's look at another question. Okay, the total number of positive integers n in the range n between 10 to 70 such that this is not divisible by n. Now this product that we have, this is a factorial. Okay, if you see it is starting with 1, go from right to left, 1 into 2 into 3 up to n minus 2 and n minus 1. This is called as n minus 1 factorial. We take the largest, so this is a product of natural numbers ending at n. So then it is called n factorial. This is ending at n minus 1. So we call it n minus 1 factorial. So we're basically saying that the number should not be divisible by any of these numbers. Okay. Now this is possible only in such case that the number is a prime number. Okay. For example, if you take 10 and you say that 10 is not divisible by 9 factorial, one less, 9 factorial does not divide 10. That is not possible because 9 factorial will have 5, it will have 2 and it will divide 10, right? The only case it will not divide is if you take 11 as your n. So 11, nothing from 1 to 10 or 10 factorial can divide 11 because 11 is a prime number. Any number that can be broken down, that will be present and that can be divided. Okay, so here we basically have to count up to 70 how many prime numbers are there, but starting from 10 we don't have to count. So I told you, if you remember, 1 to 50 there are 15 prime numbers. Let's look at beyond 50. 51 is not a prime number, 53 is a prime number, 59 is a prime number, 61 is a prime number, 67 is a prime number, 69 is not a prime number. So you have these. Okay, so 1, 2, 3, 4, 15 plus 4, 19. But in this, because this starts from 10, I'll have to remove 2, 3, 5 and 7. Right? 2, 3, 5, 7 should be removed. So minus 4, you'll have 15 prime numbers and your answer would be 15. There are 15 prime numbers and these prime numbers. So just to get the logic, hope you understand what you have done. 67. So the product is, so 67 will not divide anything of this type. Okay, because 67 cannot be broken down. But if you take 66, now because 66 is 22 into 3, you can see that the numerator will contain multiple 3's, it will contain multiple 22's, hence this will get divided because it will get factorized. Okay, but 67 cannot. Similarly, 61 cannot. Similarly, 59 cannot. And hence you get the answer. Okay, great. Okay, so let's come to the last concept for the day, which is sum of natural numbers. Very important, very interesting, and very simple. Right now in the last slide we were discussing product of natural numbers, which is factorial. Sum of natural numbers ever if you have to add. So let's say 1 plus 2 plus 3 plus 4 up to n. The formula is n into n plus 1 by 100. Very simple. So if I ask you what is 1 plus 2 plus 3 up to 100, the answer would be, or this is also sometimes called as summation 100. So it will be 100 into 101 by 2, which will be 5050. As simple as that. Okay. If the question asks you what is the sum of squares of n natural numbers, then the formula is n into n plus 1 into 2n plus 1 by 6. So if I ask you sum of squares of natural numbers up to 100, it will be 100 into 101 into 201 by 6. Okay, so this will be 50, and this I can cancel as 67. Okay, and so it is 50 into 101. So that is same, 5050 into 67. And the third formula is sum of cubes of n natural numbers. So this is n into n plus 1 by 2 whole square, which means 5050 whole square if it is up to 100 cube. Okay, of course it can be up to any, but remember that is a sum of natural numbers. So it has to start from 1 and it can end wherever it wants. Okay. Now there are two more formulas that I like to give here. Very important and very useful. So let's say that I want to find out sum of 2 square plus, or leave this even, I want to find out sum of 2 plus 4 plus 6 plus 8 up to 100. How do I do this? Now this is not sum of natural numbers, this is sum of even natural numbers. How do I find sum of even natural numbers? I'm sure some of you would have guessed. What I can do is I can take 2 out. If I take 2 out, it becomes 1 plus 2 plus 3 plus 4 up to 50. So it is sum of 50 natural numbers. So it is 2 into n, which is 50, into n plus 1, which is 51, by 2. So it becomes basically 50 into 51. Okay, or it becomes n into n plus 1 as a rule. But one word of caution here, n here is, n means what? N is the count of numbers that you have. So n is not 100, n is 50. Okay, it is because you want to find the sum of first 50 even natural numbers. Okay, so n is 50 here. Okay, second, what if I want to find the sum of, let's say, 1 plus 3 plus 5 plus 7 up to 99. This is sum of first 50 odd natural numbers. So one method obviously is that I have the complete sum. 5050. From this, I subtract 15 to 51. And 5050 also, if you remember, it was 15 to 101. So basically 15 to 101 minus 15 to 51. If you subtract, you'll get 15 to 50, which is n square. Okay, so very important two formulas more to remember. Sum of even natural numbers is n into n plus 1 and odd natural numbers is n square. Okay, but remember what is n here. N is the count of natural numbers and not the last natural number. So when you are taking the sum of first 50 odd numbers, the last number is 99, but n is not 99, n is 50 because you are adding only 50 natural numbers. Okay, that part is important and please bear in mind. Okay, let's do a couple of questions here. So it's a very similar question, but we have sum of square of first, how many these numbers are? These are 50 natural numbers because we are taking even natural numbers up to 100. So formula should be same what we did earlier. Let's take 2 square out. If you take 2 square out, you have 1 square plus 2 square plus 3 square plus 4 square up to 98 will be 49 square and 100 will be 50 square. So for inside we know the formula, n into n plus 1 into 2n plus 1 by 6, and n, remember, is 50 here. So it is 50 into 51 into 101 by 6 multiplied with 2 square, which is 4. Okay, so I'll not simplify this. This is what is your answer, right? So very simple. Okay, so same, you can have question on cube, you can have cube of natural numbers, square of natural numbers and natural numbers. You know the method in each case and accordingly this can be solved. Next one, we have now odd. Okay, so what we should do here, if you remember, I told you the method for this also, that you basically find the whole and the even and subtract them. If you don't have the formula directly. So for the whole thing, this is up to 199, you take up to 200. Okay, so up to 200, if I take then n into n plus 1 by 2 whole square. Okay, minus even. So 2 cube plus 4 cube plus 6 cube up to 200 cube. Okay, so if I take 2 cube out, then it is 1 cube plus 2 cube plus 3 cube, and this will go to 100 cube. Okay, so n is 100 here, so 100 into 101 by 2 whole square multiplied by 8. Okay, so that is what I'll subtract. Okay, so this 2 below will become 4, so it will become basically 2. So let's simplify this a bit. Here also 2 will cancel this 100. So you can see 100 square is common in both. So 100 square I can take out. So I'll have 201 square minus 2 into 101 square. That is what I'll get. Okay. So I think this is good enough. No need to further solve it. This gives you the answer for this question. Okay. Let's look at one more question. In fact, the last question for the day. And this is my favorite question. Very interesting question. Ram added all the pages of his math. And remember, in any competitive exam, you are not going to get most of the time direct questions like we looked at the last couple of questions. You always will get an application-based question, which is this. And that's where you'll have to apply the concept. Okay. So Ram added all the pages of his maths book but missed one page and got a total of 2435. Only this much information is there and so many things have been asked. Okay, now when you add all the pages of your book, basically it means it's a question on sum of natural numbers. Had you added correctly, you would have got the total as n into n plus 1 by 2. But you missed one page and you got 2435. So 2435 is of course a wrong total and it's a lower total, right? It's a lower total because one page you have missed. So, and n into n plus 1 by 2 is the correct total. So this is greater than 2435. First you have to understand this equation, right? N into n plus 1 by 2, which is the correct total of all the pages of his book, will be greater than 2435. Okay, then n into n plus 1 is greater than 4870. Right? N into n plus 1 is greater than 4870. Okay, till here? Now you will have to guess the value of n. Okay, and not very simple. N into n plus 1, if you see, these are two consecutive integers. So you want two consecutive integers which give you a product of greater than 4870. And typically, if you look at a square root, the n into n plus 1 is basically n square plus n. N square will be very big, n will be very small. So basically, how your mind should work is, think of a square root of 4870. Now nearest square root to 4870 is 4900. 4900 is square root of 70. Okay, so if I take n as 70, n into n plus 1 will become 70 into 71, which will become 4970, right? If I take n as 69, then it will be 69 into 70. So that is 70 into 70, 4900, 4900 minus 70, 4830. 4830 you can see will not satisfy this condition. 4970 is. So n is equal to 4970. That is the first thing. Okay. Now you may ask you why 70, why not 71, why not any value greater than 70, because n into n plus 1 has to be greater than 4870, so any value should be okay. But no, it will not be, and I'll tell you why. Let's take n as 71 and I'll show you later. So if I take n as 71, then this becomes 71 into 72, which is how much? 2, 14 and 7, 21, 2 carry 49, 50, 51. You'll get this as the total 5112. And I'll tell you why 5112 is not possible. Let's for the time being stick to n is equal to 70. So n is equal to 70 answers the second question. How many total pages are there in the book? 70. Okay. Then what is the correct total? N into n plus 1 by 2. N into n plus 1 we have already found out, 4970. 70 into 71 by 2, or 4970 by 2, which will give you 2485, right? So 2485 is the correct total. So 2485 is the correct total. What was the wrong total? 2435. What is the difference between the 250? So which page number did he miss? 50. So you can see all three questions can be answered. Okay. Now coming to why 71 is incorrect. Let's assume 71. Then your n into n plus 1 by 2 will become 71 into 72 by 2, which is 5112 by 2, which is 2, 11, 5, 11, 5 and 6, 2556. Okay, this is the correct total. This is the wrong total. Which page number did he miss? 121. But your book had only 71 pages. How can he miss page number 121? So obviously that is not possible, and hence this is a wrong answer. Okay, so that's why there's only one answer that will fit, and you bit of hit and trial, and very easily you'll be able to guess what value of n fits. Take the value which just exceeds. And there is another question here which can be formed. Instead of missing one page, I can say he double counted one page. He added it twice. This is also a very nice question. He added one page number twice and all the questions remain same. So the only variation now will be that instead of this greater than, you'll have this less than. Okay. So n into n plus 1 by 2 is less than 2435. Then you will go with this value. N is 69. Because now you will get 2415. Okay. Which satisfies this condition, and hence page number 20 is what he would have double counted. Pages in the book will be 69. The correct total will be 2415. Page that he has double counted will be page number 20. And there also only 69 will fit. If you take 68, again you will get a page which is not there in the book. Okay. So this is how this can be applied. So what I'll suggest is that you try all these questions, okay, and go through the whole concept. You've just started numbers, just scratch the surface. Numbers, as I told you, is a very big chapter, so many concepts there, and we will go slowly one by one. But whatever we have covered today, please make sure that you revise them, you do all these questions that we have done, and you solve some more questions from your practice material so that you are completely confident on these concepts. And I told you, you will get multiple questions on numbers in your exams. So each and every concept has to be done well, understood, and practiced a lot. Okay. So thank you so much. And then we'll meet in the next class where we are going to take up all concepts related to HCF and LCM. Okay. There are some models also that we have developed, some models on LCM, some models on HCF. We are going to do them also, and we are going to do a lot of questions there. Okay. So see you in the next class. Thank you so much. Take care. Bye-bye.